All right, so these are the 4-1A notes, talking about solutions to a quadratic equation. So in Unit 3, we did a lot of stuff with graphing parabolas. Now we are going to be dealing with quadratic equations where it's more than just a graph and we're going to be actually solving those quadratic equations. So a couple little definitions, vocab terms. The solutions to a quadratic equation are the points at which the function intersects the x-axis. So if you were looking at a graph of a quadratic function, where that graph intersects the x-axis, those are the solutions to the equation. So we've kind of seen this before, we just haven't really interpreted our answers this way. Solutions are referred to as roots, zeros, or x-intercepts. And so you'll hear those terms used interchangeably. So number of solutions. You might have two solutions if your graph looks maybe something like this. It would intersect right here, it would intersect right here. You could also see a graph that's upside down that looks like that. One solution would look like this. If the graph comes down and just bumps the axis and then turns back around, then it only has one solution. You could see something like that upside down as well. And no real solutions would be something that moves up high enough that it never actually intersects the x-axis like this, or you could have an upside down graph down here that never actually intersects. I purposely drew some that were just all right side up, but just know that you could have the exact same thing happening for those that are upside down. All right, so let's look at a few solutions or a few examples. So find the solutions by graphing. So we are going to graph these the exact same way that we graphed them in Unit 3. And we do that by finding the vertex and then setting up a table. So example number 1, our vertex when we're in standard form, we use this formula. Remember, negative b over 2a. So I'm going to write the formula once just so you know where I'm getting my values from. So negative b would be a negative 2. And then 2 times a would be 2 times 1. So this would be a 2 right here. So this comes out to be a negative 1. So when I go to set up my table, the x value of negative 1 is going to be right in the middle. And then you number down, number up. And then remember, you can use your symmetry when you're subbing these values in. So sub these values in your head, or use a table, on a graph, however it is that you want to set these up. So I am going to sub these values just into a calculator. So first one, negative 4. So I'm going to get this calculator off here. There we go. So when I sub in negative 4 squared, so I'm just subbing into this formula, and then plus 2 times negative 4 minus 3. So just subbing that value in, I end up with a 5. So if this is a 5, because my parabola has symmetry, this is also a 5. And then I do the same thing with the first few. So negative 3 squared plus 2 times negative 3, and then minus 3. So the second one would end up being 0. So if this is 0, then this is 0. Negative 2 next, negative 2 squared plus 2 times negative 2 minus 3. That gives us a negative 3 right here and a negative 3 right here. And the last one is the vertex. So sub that negative 1 into the exact same formula. And so this gives us a negative 4. All right, so I'm going to move my calculator off the screen here. So this is our table. You're going to take the values off of the table and just plot them. So negative 4 up to 5 would be this point right here. Negative 3, 0 would be right on the axis. Negative 2, negative 3. Negative 1, negative 4, 0, negative 3, 1, 0, it's right there, and 2, 5, just to finish this off. So connect the dots. We've got our graph right here. So this is our parabola. So this part, literally nothing has changed from what we were doing from Unit 3. What is different now is that we're supposed to be finding the solutions, and our definition up here says the solutions are the points at which the function intersects the x-axis. Okay, so our solutions are x equals, and then you look at the x-axis. We have one right here at negative 3 and one right here at positive 1. So our solutions over here with number 1, remember our little solution set where we had these squiggly brackets, and then you write the values in numerical order. So 2 different answers for number 1. All right, so let's do the odds. Number 3 right here, you do the exact same thing. So we do x equals negative b over 2a, so negative b would end up being a positive 6, and 2a would be 2 times 1, so we get 3 for the x-coordinate for our vertex. So I'm going to set this up. 3 goes right in the middle. I count down, 2, 1, 0. I go up 4, 5, 6. So these first 4 values, and I'm just going to do some mental math with this one. If I sub in 0 minus 0 plus 8, I get 8 here, which means I also get 8 here. Then I can sub in 1. I would get 1 minus 6 plus 8, and that would give me a 3 here and a 3 here. Then the 2, I would get 4 minus 12, and then plus 8, which would be 0. So this would also be a 0. And then 3, I would have 9 minus 18 plus 8. That would end up being a -1. So I have 7 values that I can plot. So 0, 8 would be all the way up at the top of the grid right here. 1, 3 is this point right here. 2, 0 would be right on the x-axis. So that's going to be one of my solutions. 3, -1 is just down below, and then my points start turning around. So 4, 0, that's my other solution. 5, 3 would be right here, and finish off with 6, 8 all the way up at the top. So connect the dots, make the graph just like we did in Unit 3, but then our actual solution to these problems is where we cross the x-axis. So this x value right here would be 2. The second x value right here would be 4. So I'm going to add that to my list of answers over here for number 3. So we have 2 and 4. So 2 solutions to that equation. All right, so let's go on to our next page. Keep going with our odds. So we're going to have 2 more here. Number 5, we have x squared minus 9. So we do -b, and there is no b term here, so that would just be 0 over 2a, which would be a 2. So the x value of my vertex is just 0. So I can use that right in the middle of my table when I start setting values up. So 0 goes here, which means I go down all the way to a -3, and then up all the way to a +3. So when I sub these values in, x squared, if I square -3, I get 9, and then minus 9 would be 0. So this down here would also be 0. -2 squared would be 4, minus 9 would be a -5, so would this. And -1 squared would be 1, minus 9 would be a -8, so would this. And finally the 0, 0 minus 9 would be a -9. So even though that would be off the grid, since it's the vertex, we want to make sure that it ends up there. So -3, 0 would be right on the axis here. -2, -5 would be right. Oh, sorry. Oh, we purposely got a bigger grid. Hold on. 1, 2, 3, 4, 5. There we go. Made it just a touch bigger for us. Nope, let's try that again. 1, 2, 3, 4, 5. There we go. Sorry. -1, -8. So 6, 7, 8. And 0, -9 would be right there. Then start going back up. 1, -8. 2, -5. And 3, 0 would be right on the axis. So ignore that lower point. It should be the higher point. So connect the dots right there. That's our parabola. Remember, the important part with these are where our x-intercepts are. So solutions would be where the graph crosses the x-axis. You've got one right here at -3. And then if we trace over, we've got one right here at +3. Okay, so 2 solutions for number 5. I'm going to add that over to our list. We have x equals, curly brackets, got -3 and +3 would be our 2 solutions for number 5. Okay, we're going to do one more for this set. That would be this one right here. So we can do x equals -b, which would be a -8 over 2a, and that would be 2 times -1. So that would be -2. So this is 4. So 4 is going to be the x coordinate that we put right in the center of our table. So right here, then we go down, 3, 2, 1, go up, 5, 6, 7. So these values, you can do mental math, or you can plug them into your calculator, whichever is easier for you. So 1, when I sub in 1 here, I'd get a -1 plus 8, so that would be 7. And then minus 17 would be a -10. This is also a -10. Then 2, this would be a -4 plus 16, that would be 12. Minus 17 would be a -5. Then the 3, this would be a -9 plus 24. So a -9 plus 24 would be 15. Minus 17 would be a -2. And the 4, this would be a -16 plus 32, which would be 16. Minus 17 would be a -1. So we have 7 points there that we can plot on our grid. So 1, -10 would be all the way down in the bottom spot right here. 2, negative 5, 3, negative 2. Next one is 4, negative 1. Then they start to turn back around. 5, negative 2, 6, negative 5, and it finishes off here at 7, negative 10. Okay, so connect the dots. We've got our graph, nice parabola, just like we did in Unit 3. And then remember, the point of these problems is where does it cross the x-axis? You can see here, this is my x-axis. It never crosses. So I would say that there is no solution here. So for number 7, when we are looking for x-intercepts, we don't find any. So we would say no solution for number 7, or that symbol that I just wrote down would work as well. All right, so that's the first half.